this video we're going to talk about how do we rationalize the denominator when the denominator has two terms. And just a reminder what we mean by rationalizing the denominator. That means getting rid of any radicals that are in the denominator and ending up with an integer. And an integer is part of a set of numbers called the rational numbers. So that's why we call it rationalizing the denominator. Now, for denominators that have only a single term, we rationalize the denominator by multiplying or getting a perfect square under the radical. Oftentimes when my students will first look at an example like number 1, I will ask them, how do you think we're going to rationalize that denominator and get rid of that square root of 11? And so oftentimes students I'll let them have guesses at that. And so oftentimes the first thing that they will think of is, well, why don't we just multiply by another square root of 11, because that worked in the last section. So I want to show you what happens if we do that. So here I'm going to put on this side. So here's our fraction. And now if we multiply by square root of 11, so this was the technique that worked for us previously, right? Then I just want to remind you that we would be distributing this square root of 11. And so then what would we get down here in this denominator? Well, we would get 3 square root of 11 minus, and then square root of 11 times another square root of 11 is square root of 121, or 11. So even though our radical is gone from this term, we've now moved it over to this term, and the denominator is not rational. It's not an integer, and there's still a radical. So that technique, that's not going to work. So then my students will say, well, how about if we just square the denominator? What if we just multiply by another 3 minus square root of 11? And notice how I'm writing the same thing in the denominator and the numerator, because we would be multiplying to make an equivalent fraction. Okay, but I'm going to ignore the numerator and we're just going to look at this. Now remember that we multiply this by foiling, right? So first, outer, inside, and last. So what would that give us? So 3 times 3 would be 9. Then 3 times negative square root of 11 is negative 3 square root of 11. And then the insides, a negative square root of 11 times the 3 is another negative 3 square root of 11. And then with our last, the negative square root of 11 times the negative square root of 11 is a positive square root of 121, or 11. So look what happens here. We still have a middle term, a negative 6 square root of 11. And then these two are like terms, and the 9 and the 11. So I can write 20 minus 6 square root of 11. So again, that technique of just squaring the denominator, multiplying by another one, that doesn't work because we still have that square root of 11. So we need to multiply this 3 minus square root of 11 by something that will have us end up with no middle term. Because it's the middle terms, isn't it? It's the middle terms over here that are allowing us, let's use the highlighter, it's the middle terms here that are giving us the problem. So then you might remember that the way for us to multiply a binomial by another binomial and not get a middle term is if we use the conjugate. So that's the technique we're going to use. So a reminder that the conjugate, you just change the middle sign, right? So the conjugate of 3 minus square root of 11 would be 3 plus square root of 11. Okay, we're going to see what that does. And so again, whatever we do to the denominator of the fraction, we have to do to the numerator. And let's do that part. So our denominator, then we get 3 times 3 is 9. 3 times the positive square root of 11 is plus 3 square root 11. Negative 3 times a 3 is a negative 3 square root of 11. And then negative square root of 11 and a positive square root of 11 is a negative square root of 121, which we know as 11. Look at what happened here. Those middle terms are gone, and we end up with 9 minus 11, or a negative 2 in the denominator there. Then in the numerator, now you might be tempted to go ahead and distribute that 6. And normally I would say, yeah, let's do that. But I'm kind of looking ahead here at this negative 2 in the denominator. Yeah, because I noticed that I can do some reducing. So I'm just going to write that here. And then I'm going to do this division. So we have a 6 divided by a 6 divided by a negative 2, which is a negative 3. And that negative 3 I will then distribute. And my answer is negative 9 minus 3 square root of 11. Okay, let's try the next one. All right, so we have negative 8 divided by 3 plus square root of 5. And so again, because this is two terms, we're going to use the conjugate. Okay, so we're going to multiply by 3 minus square root of 5. Whatever we do to the denominator, we do to the numerator. And then we're going to multiply down here, and it's 3 times 3 is 9. Now, we know those middle terms are going to cancel, right? We know that we're going to get, this is the difference of squares. This is going to be a squared minus b squared, right? So I'm just going to go ahead and do that. Just a reminder, when we multiply those two, we get difference of squares, right? So I can square the 3. So 3 squared minus square root of 5 squared. And what's the square root of 5 squared? Square root of 25, which is 5, right? Remember, these undo each other? So I get 9 minus 25. See what we did there? Kind of saved us some time, right? And then over here, I'm still having that negative 8 times 3 minus square root of 5, which I'm not going to distribute yet until I see what's happening down here. Maybe I can reduce, right? So 9 minus 25 is a negative 16. Ah, isn't that nice? That's going to be good with that negative 8, right? Okay, and so we're going to go ahead and reduce those. Yeah. Negative 8 goes into itself once and into negative 16 twice. So I get 3 minus square root of 5 all over 2. Okay, you can write this two ways. You can leave it like that, or if you want to separate it into the two fractions, that's okay too. It's up to you.